Hi, this is Mr. Ing, and this is the quiz corrections for Math 4, quiz number 12, which was on sections 9.1 to 9.4 on February 19th, 2016. This is primarily about Chapter 9 in circles. Question number 1 is multiple choice. In the circle O below, so O is the center, BO, segment BO is so I start on one point of the circle and goes towards the center, that's called a radius. Same picture in this problem. They want to know question number 2 in circle O below AB. Now you have the symbol above and it looks like a curved part, so that's called an arc. The answer is D. Radius in this picture, like in the previous problem, OB would have been your radius, or AO or CO or DO. A diameter is a chord that goes through the center, so here's a chord BD. And if you wanted to know a central angle, that would be a little angle here, like BOC, AOB, DOC, or AOD. Question number 3, also multiple choice. I don't know if I can get it on the screen. In the diagram below of O, chords AB and CD intersect at E. If CE is equal to 10 and ED is equal to 6 and AE is equal to 4, what is the length of EB? So this is the center. I have two segments that intersect inside. So segments that intersect inside. Segments inside. Look at your formula sheet. That would have been small times big equals small times big. So you can just take this information, CE, put it on your picture. There it is 10, ED is 6. AE is 4, and then notice you don't have anything for BE. So this is your small, this is your big. I'll call this one your small and that one your big. Now here you don't add any length, so it's just 6 times 10, 4 times EB. You get 60 equals 4 EB, divide by 4. EB is equal to 15. Question number, let's see. Question number 4. In the accompanying diagram, ray PA is a tangent to the circle at circle O at A. Segment PBC is a secant, and PB is equal to 4, BC is equal to 8. So take your information, label it. PB is 4. BC there's 8. I know this is a tangent, so it's only touching one point at A. And they're saying this is a secant, which means it goes through the circle, intersects at 2 points. So this problem is talking about segments. I asked the question, where's the segment vertex? On your map, you can look. That is on the outside. Therefore, exterior squared equals exterior times the whole. In this problem, there's two equations that have segment and vertex is outside, and the reason why I chose the one with external squares because I see only this outside part. And notice how you don't have anything over here, so your exterior would be x. Your exterior on this side would be 4, and this one would be the whole, 4 plus 8. This was the major mistake for most students. Anytime you have a whole, it's asking for CP. In that case, you don't multiply, you add segment addition postulate. 8 plus 4 is 12, 4 times 12 is 48. Here, to get rid of the exponent, take the square root of both sides. Factors of 48 are 16 and 3. 16 is the greatest perfect square. The square root of 16 are factors of 4 and 4. If they're a pair, they come out. Your answer is 4 radical 3. That'll be choice C. Question number 5. In the diagram below of a circle O, secant AB intersects circle O at D. So again, AB, that means it's going through the circle twice there. It says AE is 4, so put that in your picture. You have AB here is 12. So you know that's the whole, right? And then DB is 6. Well, if I know this is 6, this has to be 6. 6 plus 6 is 12. What information? Let's see, 4. So where is the segment and vertex? It is outside. We're talking about segment lengths here. We're not talking about angles. These aren't angles, these are segments. So it is outside, therefore I'm going to use external times whole equals external times whole. Your external out here is 6, but be careful, your whole is 12, or 6 plus 6 is 12. On this side here, I have, here is 4, and it's asking me for the length of OC, which is a radius, but I don't know this whole diameter here. So I'm going to call EC X. So it's essentially, to get the whole, it's X plus 4, and that's what I have here. You could distribute, or you recognize this is multiplication, so you can divide by 4 on both sides, subtract 4, and you get X equals 14. Now if X equals 14 here, this whole length, then I can break it in half because I know the diameter is 2 radius, right? Or diameter equals 2r, so therefore OC is equal to 7. Question number 6 is a Ken. Fill in the blanks so that each row and each column all have the numbers 1 to 4. Numbers and cages may repeat as long as they are not in the same column. So I need the numbers 1 to 4. Take a look at it. Those are my answers. There's no repeating numbers, right? Has all the numbers 1 to 4 in each row. Look for the freebies. You have 2 freebies here. There's a 4 and a 4. It's called a cage because it's darkened. For example, this is the outline of a 1 cage, but you have to put 3 numbers that multiply to be 3. That would have to be 1, 3, and 1. Put a 4 there, put a 4 there. Therefore, this number must be a 2. This says 2 numbers that divide it to be 2. Direction is not important. For example, this one over here says this is not a negative 3. It just means the 2 boxes. Doesn't matter which order. You subtract them and you'll get 3. That side was worth 14. Question number 7. You guys actually had this already on your practice test worksheet. Assume all lines and segments that appear to be tangent are tangent, solve for x, show all your work, and box your answer. So in this problem, you have 2 concepts here. This one is center. If it's center, then your angle is equal to arc. So this is the angle. You just draw your arc up here, which is x. Next time, as you see, these are degrees. So your angle vertex is here on the circle. Just look at your map. Angle equals arc divided by 2. This is an angle, so you just put in 60 here. And your arc, the intercept arc from these 2 lines is x. To get rid of x, you multiply 2 on both sides, therefore x is equal to 120. A lot of students who try to solve this without the formulas, and you're wrong, only can give you 1 point for trying. If you got the formula, at least I'll give you 2 points. Question number 8. This is segments. It's outside. In this problem, you have to use external squared because remember, there's nothing else past here. And also, it doesn't go through the circle on that side. So your external is x squared. Remember, look at this side. You have 6, and then it goes through the circle, so that's the other part. So this is your external, which is 6, and then your whole is 4 plus 6. Remember, segment addition. A lot of students try to multiply there. That would have been incorrect. 4 plus 6 gives us 10. 6 times 10 is 60. Take the square root of both sides. Factors of 60 are 4 and 15. Square root of 4 is 2. X equals 2 radical 15. Question number 9. Notice how you have this x here, and a lot of students thought, you need this arc, and you also need this arc. But I gave you the numbers on the opposite side. So a couple of ways that some students did it is that you could just figure out, well, you don't know that this is a diameter, you don't know that's a center. But students did recognize that you were missing a total value. You can add these 2 values together and get 286 and subtract that from 360. And that would be the values you were missing there. If you're big and you're small, you could just divide that by 2. The way I solve the problem is I recognize that this is a chord, therefore it has to be a line, so a straight angle, so I call this one y. So my intercept arc is 150, and from this line here it is 136. That's my big and my small. Add those together, you get 286. Divide that by 2, you get 143. Now, if you left your answer as 143, I give you 3 points because you're looking for x. So you just realize that they're supplementary or linear pair. Subtract that from 180, and you'll get 37 as your answer. Let's see. Question number 10. These are angles, and your vertex is outside, so that would be big minus small divided by 2. This is your angle, which is an unknown, so you call that x. Your small here is 60, and your big is 140. Subtract those two, divided by 2, and you get x equals 40. Let's go back up to question number 11. Oh, sorry, I have two number 10s. Need to fix that. In this problem, you need to locate where is the angle vertex. Again, it's here on the circle. Your equation is angle equals arc divided by 2. This one's looking for x. So again, you can introduce a new variable here. I did y. Angle equals arc divided by 2. My angle is y. My arc here goes from this point all the way around the circle to there. So that would be 220. 220 divided by 2 gives me 110. And again, linear pair supplementary, and you get subtract that from 180, you get 70. Another way of doing the problem is just taking 220 and subtract that from 360, so you get 140. So this arc here is 140. Angle equals arc divided by 2, so 140 divided by 2 gives you 70. Question number 11, two segments that intersect in a circle. Remember, you don't know where center is. So 3 times 4 equals 2 times x, and you'll get x equals 6. Question number 12, you have an outside. These are segments. So external times whole equals external times whole. Again, you have two values there, so that can help you. So you have external is 4, and then your whole is 4 plus x, not 4 times x. You can distribute here if you wanted to. Let's see what I did on this side. I did 6 and then 6 plus 10, which gives you 16. Multiply, divide by 4. You get 4 plus x equals 24, and then subtract 4, you get x equals 20. A lot of you guys are messing up on the algebra. So if you have like this part right here, I'm giving you 2 or 3 points, right? You have the formula, you have substitutions correct. Last question. I'm supposed to get you in there. MQ and NR are diameters. So MQ, that's telling you that's the center. And R, straight lines, right? Find the indicated measures. So they give you 70 here. You can use vertical angles, right? Same two lines. Opposite sides are congruent, so that's 70. Okay. This one is not 30. This is saying that little in this area, that's 30. Okay? So if NR is a diameter, I can say 70 and 110 or 180, right? Diameter makes a semicircle. Therefore, these have to be 180. Also on here, so if this is 30 and 70, that's 100, and that's 100. So therefore, this angle over here, NOP, has to be 80. These are at the center, so angle equals the arc. So NQ, you're going through these two values. You're going to have to add 80 and 30. Remember, you can just take out this 80, put it out here. Put this 30 up here in the arc, because angle equals arc. The measure of arc MRP, so go in that order, M, R, and then P. So I know I have all of that's 180, because MQ is a diameter, plus another 30 would give you 210. MR, 110, and arc PQ is 30. That's just from the picture. That side was 32, and then the quiz was out of 46. I hope that was helpful for you to study for your tests. Good luck.